I'd like to highlight this invention as one of those inventions that I don't really see used directly. At the moment there's kind of a lull in the building of solar panel plants. I guess investment has been booming for a couple of years. Now there's overproduction, and you can see that because solar panel prices are going down. So maybe that's a good opportunity to integrate this technology. This is basically an invention of China, Chinese universities here at Hefei and Beijing, Chinese Academy of Sciences and the University of Science and Technology of China in Hefei. They used concentrated solar power to do one of the processes that is important in the manufacturing of solar panels, which is to purify the silicon. Silicon is sand. It has all kinds of impurities in it, and they have to be removed in order to increase the yield of the final solar cell. Usually that's done using chemical processes. Here you may see that it's like here you start with a pile of sand and you purify it, you put it in all kinds of chemicals, and then you heat it up. You have to slowly cool it down so it forms a crystal, and the crystal is optimal for making the panels. Such a crystal looks like this. It's a big ingot of basically stone. It's cut and sliced, which is also energy intensive, and then it's processed into the solar panels. Solar panels are basically a containment, a way to protect the different the slices of this the wafers that are made from such an ingot. Well, the Chinese process is not very complex. It takes the step of the purification of the silicon and uses concentrated solar power to do it. They have this big heliostat mirror. It's a moving mirror that moves with the sun and also focuses the light on one spot that gets very hot. It says here it's 1700 degrees Celsius, 10,000 sun. They put the silicon in that spot in the focus of the light. It melts very quickly. It evaporates almost, and then it condensates, or it solidifies again. It falls down into a container with some acid. Well, this process, this evaporation and solidification, is actually the purification process. The acid evaporates, the metals separate out. Maybe they burn into the air, or they do something else. They drop down with the little silicon pebbles or drops and fall into the acid, and they dissolve in the acid. So after the process is done, you have a container with acid which has metals dissolved in them, and you have silicon on the bottom. Very easy to separate, and you can then take the silicon and go to these steps, put them in an oven, heat them up and cool them down, and you end up with this. Well, this step alone is a very important step, because they talk about it here. They say, well, the primary advantage of the new process is the energy consumption can be as low as 30 to 40 kilowatt hour per kilogram, which is negligible with negligible emissions of hazardous gases, because the only thing that happens is that the hot silicon falls into acid container, which can be closed off, and protection and safety measures can be taken. Unlike the traditional process, which requires 200 to 400 kilowatt hours per kilogram silicon and emits significant amounts of hazardous gases that require considerable effort to deal with. So this is a very good invention. It not only cuts the energy consumption of this step in 10, so a tenth of it, but it's also safer for the people that have to do it and safer for the environment. If you look at the overall price, it reduces the price of solar cells by about 20% or something like that. This is one of the parts of the process that can be done with solar energy. Of course, the other parts of the process, like the slow annealing, as it's called, of the ingot, can also be done by heating it up using concentrated solar power in the beginning, and then waiting for it to simply waiting for it to cool down or control that process. I'm not sure how you could do that, but of course it's simply input of energy. I thought it's interesting to show you. I'll link to this article. It's in Dutch, and I'll also link to the the different or this paper. There's of course one of the concepts that I really like is the idea that you start in a place where there's lots of energy available, solar energy, so it's a desert, and you build from that simple concept that the energy is there. You build everything you need using it, and you mine everything you need using that solar energy. You know, once you have the technology to convert solar energy into liquid or storable energy, then you are actually exactly where we are today with oil, but the resources is unlimited and it's non-polluting. I'm not the first one with that idea. It might be interesting to show this. This is called Sahara Sun, and it's called the Sahara Solar Breeder Project. It's a Japanese project that already has some funding, and they are thinking about going into the desert.
The JST and JICA. 一番ベースを確立していこうと。で、例えば砂漠の砂から年産1トンのシリコンでいいからとりあえず作れる技術を開発。
So this Japanese guy is saying, well, you know, we have sand in the desert, we can turn it into solar panels. That can mean energy. The energy can be used to build another solar panel plant, and so we can expand and expand ad infinitum.
To demonstrate the possibility of manufacturing high purity silicon from desert sand and constructing a high temperature superconducting long distance DC power supply system. The aim is to achieve a solar plant with annual capacity of at least 100 gigawatts, which would truly help to solve the world's energy problem. Another major goal in this project is to train scientists and engineers from developing countries. そのためにはやはり今分かっている技術を先進国からそういった太陽光発電。
Now,
Believed to be the power of the sun god Apollo. The idea, by doing so, this project could transcend the original Apollo project.
the thing I have against it is that it's again looking at a super grid, and it's all smart grid, and of course the easy things are done first. A lot of money can be spent on educating people, and of course you're not only educating them, but you're also keeping them from doing anything useful. You can also teach them exactly what you think is the right approach, which may not be the right approach, because I think that the right approach is to apply inventions like the one that I've shown as fast as possible, and use concentrated solar power instead of a PV for most applications. But anyway, I hope you find this interesting, and check out the link, and maybe somebody will build a solar silicon purification installation using this technology soon.